Hi everyone, I'm Sarah Hagen. I want to talk to you today about the Illinois State Fire Assessment and how we use LANDFIRE data and how you can potentially contribute to an effort to improve some of that data to make it a little bit easier maybe for some others to do these assessments in the future. Before I talk to you about what we did, I want to take a minute to explain to you what LANDFIRE is and kind of give you a little bit of background in the LANDFIRE project because it's pretty cool, but it's pretty complex. So LANDFIRE was developed with a fire focus, but we also mostly actually explore how LANDFIRE products can help offices achieve both fire and non-fire goals. And it's funded by the U.S. Department of Agriculture, the U.S. Department of the Interior, and TNC, who you can see on the bottom there. And they're mapping several metrics and identifying areas that are closest to and farthest from the reference ecological conditions. And so we just want to say that while LANDFIRE was developed for national or regional or basically large landscape analyses, these products do have relevance for smaller geographies. And that we know that data is often the most limiting factor in assessments like this because it's hard to put together landscape scale data sets. And so we have created a set of comprehensive cross-boundary consistent data to help you guys and others do assessments like this. And I think that's part of the power of LANDFIRE is that we've got consistent data for the whole country, and it's really hard to get that stuff. So, basically, in summary, what is LANDFIRE? It's a huge repository of data, of information, community of partners. We deliver reference condition models and descriptions, spatial data, research reports, tutorials, user guides, all sorts of cool stuff. If you dig into the websites that I will list for you at the end, there's a whole bunch of stuff there, and it's a really great resource. So in this assessment, here's a list of, I think, all of the LANDFIRE data products. And the ones highlighted in boldface are the ones that we used for this assessment. And so these are the ones that I think are the most relevant to what we did here and what others would probably use, although it is possible that some of the fire and fuels data would also be helpful in planning some assessments like this. The first product we are going to talk through is LANDFIRE Biophysical Settings. And so what this does is we describe how 1,300 plus ecosystems looked and worked prior to European settlement. And it breaks these ecosystems into 5 or fewer succession classes, sort of defined by species, percent cover, and height. And then we have these cool models called vegetation dynamics models that model the percentage of each of these classes on the landscape. And a note that I like to give people about using biophysical settings as sort of the reference condition is that we aren't looking at climate change with it, and we understand that reference conditions are not necessarily your desired future conditions, but we think it's a helpful place to start, basically. And so sometimes departure means higher vulnerability to climate change, and we can look at reference versus current to sort of make an assessment. So hopefully what you've got here is at least a good baseline, and you can adjust depending on what your needs are, essentially. The next data set is the mean fire return interval data. And this basically what this does is looks at the average period between fires under the historic fire regime, which is again calculated from these vegetation models and the biophysical settings layer. And it's sort of intended to describe one component of the historic fire regime in the context of broader time. And we often use it in landscape assessments like this, and sort of you can see that the darker colors have a more frequent fire return interval, and the yellows and greens have a less frequent. So in Illinois, it's, most of the state has a pretty high fire return interval, which we expect if you look at the historic vegetation being mostly grassland. The other thing we looked at, which I'll touch on here, we didn't end up using really in my assessment. We thought we might need it, so we did it, but we didn't put it in a lot. But we looked at the fire regime groups, and what this does is it groups the fire return intervals together, but mostly it provides a sort of a measure of the severity of fire. So low severity, mixed, surface, and replacement. So we could just sort of get an idea of how intense these fires are, not just how frequent, but how serious they are. Um, which I thought we would end up needing, but it turns out we just sort of made a measure of fire versus not fire. So summarize a little bit about what I said. Basically, these models represent how the ecosystems of the US worked prior to major European settlement. And they come in two parts. They come with the model part and the description part. And like I said, it's not a prescription for how things should be today or tomorrow or, an exact measure of how they were. You can modify them, and it's not that hard to modify them, actually. It's pretty easy, and people have done some pretty cool stuff modifying these models. So this is just a little bit of a picture of the back end non-spatial piece of this, the vegetation dynamics models. And there's state and transition models that sort of qualify the pathways or quantify the pathways for succession. And they are accompanied by a description document that sort of talks through site characteristics, geographic ranges, characteristic species for each of these biophysical settings. And then these models were used to estimate the reference conditions for each BPS, so how much of each succession class would be on the landscape. So all of these pieces all go together. And when I used the vegetation dynamics models, I was interested in this spreadsheet that sort of comes out that breaks down the percentage of all the succession classes and then also the fire return intervals and the severity. So that we could say, okay, this vegetation type has a historic fire return interval of this, and we can then move on to the next phase of the project, which is this, basically what I just said. We took how many acres of each biophysical setting type were on our landscape. We divide it by the fire return interval, and that gives us how many acres should burn each year. And then initially, again, I separated it into severity, but we ended up just grouping them all back together anyway, so I won't talk about it a lot. But it's something we thought to do and may be useful, but we couldn't manage to figure out how it fit in. So again, first thing was calculate how many acres of each of these biophysical settings types are on the landscape. So as expected, we have a lot of tallgrass prairie historically. So, that was the dominant type on the landscape. And just basically, I'm showing you the 5 most widely distributed types in the state. The numbers and the types aren't really important in the process. It's just some relevant, here's some numbers so we can talk about the math. But so again, to calculate how many acres of each of these should burn per year, what we did was take that mean fire return interval number from the previous table, divide the acres of each of those types in the state by that fire return interval number, and that's a really rough measure of how many acres we should be burning per year. So it's what we can kind of refer to as our historic baseline of fire in the state. But because we don't necessarily have that many acres of vegetation that will actually burn, and in fact we have almost none of that because of how Illinois is, we knew we needed to identify a current area of interest. So we wanted to identify the existing vegetation classes to eliminate from analysis. So basically, we needed to mask out anything from that was agriculture or urban or a few other types. And then we needed to simultaneously mask out anything from that historic analysis that's in those eliminated vegetation classes that were matching the extent, because it doesn't make sense to calculate current vegetation acres and then try to match that to full state acres. You're never going to get the same numbers. So Basically, we just needed to take out what we considered non-natural, although we left a few things that are non-natural in just because of the state of vegetation in that part of the world. So I started with existing vegetation type. You can see we have far less tallgrass prairie currently than we did, which doesn't probably surprise anyone on this call. And so we basically just took everything in this that was listed as urban areas or agriculture, which are the pink and the yellow, and then a few other things that were non-burnable systems. And what we ended up with is this. So far less acreages, but still quite a bit of the state. We still have a lot of one vegetation type still. Mostly along rivers. So it's still a good amount of land that could be potentially holding fire. And so the types in the table are what we took out. So just a little idea. And so yeah, most of what's remaining is the north central interior dry mesic oak forest and woodland. So it's not it's a fire dependent system, although I'm not sure that it's hugely represented in actual ownership because it's very riparian in Illinois. So fire gets a little weird. And you can see in the south there's actually quite a bit of diversity of landscape down into the Illinois Ozarks, which is good. So I masked out basically I matched the extents between the biophysical settings layer and the existing vegetation layer so that we could compare acreage historically to what we were looking at now. And those are our new acres. So again, far, far less of the central tallgrass prairie remains, which again, I think is not surprising. And then what I did was adjust the acres burned per year based on these new extents so that we could use these acre numbers and then divide those by the fire return intervals, which are exactly the same as they were. It's the same number I pulled out of the document. So it doesn't say, that current vegetation we can expect this level of fire frequency, and in fact you'll hear that we shouldn't and we didn't. But it gives us a place to start. Here's historic conditions. Here's the baseline. So that brings us to current fire need. Like I said, the historic numbers are fine, but when I started showing them to land managers and anybody involved in fire in the state, they sort of said those fire return intervals aren't realistic, and I agree with them generally. They know more about it than I do. So but we have these numbers, these historic numbers of how much fire should be on the ground, assuming that current vegetation matched reference conditions, and that the historic numbers are correct. So, the first issue that we identified is that fire needs are in many cases very different than they were when we had less of a threat. So we knew we needed to adjust those, and a lot of assessments just sort of stop there and use the mean fire turn numbers, the historic numbers, and sort of say, okay, that's fine. Historically, we had this much fire per system, but that wasn't working for us, and we couldn't get people to buy into that. So what I did was I took the existing vegetation and the BPS extents, and so I matched the classes, which is a little bit tricky to do actually in LANDFIRE. You have to match the codes, which don't always match exactly, and then applied the historic fire return intervals to that existing vegetation. So any naturally vegetated EVT type will have a fire return interval for a LANDFIRE model, so that's pretty straightforward. But if it wasn't a natural vegetation type that existed historically, it doesn't have a fire return interval. So you have to decide if you want to just eliminate those or you want to match them to a reasonably relevant type in the biophysical settings table in the historic numbers. And we chose the latter. So we essentially created this table. The top 25 or so are the vegetated classes that were matched up between the two existing vegetation and historic vegetation. And then the things below that, we sort of had to come up with a fire return interval. And we just did that sort of by having a quick discussion at first and filled in the numbers. But the team, it was a very small team. There were 3 of us working on this, and we knew we weren't the experts here. So what we did was we asked the experts. So in order to calculate the current fire regimes for the existing vegetation areas, we surveyed fire managers and experts across the state, and we asked them to provide us with a range of intervals under 2 different scenarios, because we understand that sometimes you're maintaining a landscape that's in really great condition, and sometimes you're restoring something that's not, and those numbers are often different because it takes a lot more fire in many cases to restore something that's in pretty bad condition or has a lot of invasives. So we asked them about both. And basically, this is a snapshot of the survey that came back. A note in this is that I had to essentially crosswalk our existing vegetation data to the Illinois Natural Areas vegetation, because the land managers didn't understand our classification the way that they understand the INAI classification. That's their local land cover, and they were way more comfortable working in that, and it was easier for them to give me numbers in a system that they knew. So our team sat down and sort of talked through how we thought those existing vegetation types matched up with these INAI types, and then sent out this survey. And this is the number for maintaining community types, and I basically calculated the median of all the responses, which is in the far right column, to get somewhat of a measure of capturing all of these in some meaningful way. We tried a few different sort of aggregations, and median seemed to work out the best for everyone. So the restoration numbers are here. It's the same table, it's just got different numbers in it. And this is the crosswalk. It's fairly complicated, but also fairly straightforward. If you have some understanding of both of these types, which I do, and I thankfully had some friends to help me with it who understand the INAI types way better than I do. So we basically just did our best to match this up, and then once we got our median numbers, we matched essentially so that we could put those new fire return intervals into the LANDFIRE existing vegetation data. Since that's what our historic numbers were, we wanted to make sure that we could make a comparison across all 3 of these scenarios. So this is the table that sort of shows our 5 representative systems. The fire return interval for maintenance and for restoration. And so you can see the restoration, which is taking something that's degraded or in worse condition and restoring it, has in a lot of cases more frequent fire return interval than just maintaining something as it is. If we had a really good example of tallgrass prairie, we maybe don't need to burn it as often as we do if we're trying to keep out a lot of bad stuff, or same thing with some savanna communities. So it's the same calculation we did in step 1. I just divided the acres by the fire return interval to sort of get us a number of how many acres we thought we should burn each year. And this is some maps to show that, and you can see as we progress up this chain, we're talking about a lot more acres. And so the historic, using the historic numbers, the numbers from the LANDFIRE models, according to the land managers, that estimate was really, really low, and we should have way more fire than that, and fire should be happening way more frequently than that. So that's why we updated this, because they looked at that and said that's not realistic. We're burning that system way more often than that. And so I'm going to take a brief digression into an opportunity for you all to help us make those historic data better. So right now we've got a review of this data, BPS review going on. And so you can offer input on changes to these fire regimes, to succession classes, to the vegetation characteristics. And the cool part about LANDFIRE is that it's a dynamic program, and it's got a community that we can all come together and make it grow and change and make it better. And that doesn't work unless users share their expertise with us. We can't do it all. We don't know all these systems the way that all of you know these systems that are out there working in them every day. And so the BPS review is essentially 3 steps: model cleaning, model updating, and model delivery. And so if you know at all how vegetation systems function, or have ideas on how we can deliver this information, we really want your input, because again, we don't know everything about these systems the way that people who are in them every day do. So a little more. This is some things about, the user community is really important to using LANDFIRE products. We've gotten so many responses from our users that sort of said, "Hey, we tried this, it didn't work. We think this. Here's some input," and we've incorporated a lot of this. This is the website you see here is landfire.gov, the federal website, and they love to hear from you on how they can make the maps better and improve things. So we have plot data you can see listed there, and that those plots are really important to the mapping and basically are the foundation of our spatial data. And we gather plots from existing data sources, but users can provide us with plots and provide us with feedback on what we've got, and we are always looking to incorporate that. So again, I briefly mentioned the process. It's 3 steps: cleaning, updating, and delivery. So we've cleaned the list. So we took out all the duplicates and put everything together in a sort of easy to use, easy to access table, and posted all of the PDF documents on a website that's dedicated to the BPS review. You can see a screenshot of the homepage on the bottom, and the website is above it. And basically, contributors can review the Word document and the description, and the model, or both of those things. The model being the sort of box and arrow state and transition that I showed you earlier. So most of the review is conducted in your location. You can sit at your office and do it. You can sit at home on your laptop, wherever. And although we will hold training sessions, WebEx sessions, or group sessions on site, if there's enough need for that, we will come and host a few of those, and we've done a few already, and they've been really successful. We've gotten a lot of really good info from people. So I'm gonna go back to what I did. We have these numbers, and we have this fire return interval, and we have how many acres we should burn. So the next question, after everybody was like, well, we're reasonably happy with what we've decided the fire return intervals were, the next question that we were asked was, but how are we going to measure how we're doing? Like, we have this historic data, we have this updated fire return interval. What's the comparison? Do we have measures of how much fire we have? How are we doing in comparison to that? And I think that's a big question among everyone who undertakes these assessments, is how do we measure a success in this? And we've quickly found that no one has yet found a good, reliable, and accurate way to measure current fire on the ground across the state, or even a larger set of geographies. But there are a few resources available. So um, land fire disturbance and or other data, you can get an annual area burned per existing vegetation type, which can somewhat give you an annual fire return interval. And then the Landfire Modeling Trends in Burn Severity database is on the landfire.gov website, and they collect some national trends, and federal agencies sort of input some things into there. Both of those databases, the disturbance database, there's some input from agencies about what fire, how many acres of fire they're burning. State and local agencies have some burn records. If you can talk with private landowners or just make contacts with agencies around your state, they keep good burn records. They don't always put them together in a place that's accessible to someone, so you sort of have to come together around it, and that's what we did in Illinois. We knew we were going to have to reach out and sort of do another survey of people to say, all right, thank you for your input on what we should be doing. Now tell us what we are doing. So we requested data from Illinois fire managers, and that was the total acres that they owned, and then the acres in non-habitat acres, which I'll define a little bit later. It's the non-habitat versus degraded versus burnable is a little tricky, but I'll try to get to it a little bit later. But the acres burned between June of 2014 and May of 2015. So that sort of year of fire cycle. And then what were their obstacles to implementing fire? And I want to say that my colleagues, Bill Kleiman and Mike Saxton of the Nachusa Grasslands Preserve in Illinois and the Illinois Prescribed Fire Council, took on all of this work while I was busy in graduate school, and I am eternally grateful to them for doing that. And then so they sent this survey out to state and federal agencies and private groups around the state, and respondents included federal, state, and local agencies, some not-for-profit land trusts, a university, and actually one private individual. We had 25 agencies responding to this, and representing more than 1 million acres of ownership across the state, which allows us to create a pretty good picture of what went on in prescribed fire in the state, and sort of compare these numbers and make inferences about what we're doing in Illinois, which is great. It was great response. So, boiling it down, what does the assessment tell us? Probably nothing surprising to anyone. Again, we need to burn more. We need to burn with higher frequency. We have far too many areas that are considered ecologically degraded and might not even hold fire. And in order to do all of that, we need more resources and more funding. That's sort of the picture of fire, I think, in many places, and especially in the central US. So, but we'll dig a little deeper. We'll look at what was burned in that particular fire season. So something to note is that we burned only 9% of our quality burnable acres. And those are so basically interpreted as higher quality areas that are capable of carrying fire and to which managers would apply prescribed fire if they had the capacity. And then we burned only 6% of the total habitat acres, which the assessment defines as combined total of burnable acres, so those good quality ones, and degraded acres, which might carry fire, might not carry fire. So then we ask the questions, okay, so we have these percentages. How is that good or is it bad? It's bad. And how bad is it? So this is some graphs to show you we're not burning frequently enough. So this is some graphs based on our responses from the fire return interval survey to sort of break down prairie communities and forest communities into frequency of response for. So for the most part, we saw that if for restoration, prairie and grasslands have about a 1 to 2 year fire return interval. Savannas, woodlands, forests have about 1 to 3 year, and maintenance phase was prairie was about 2 to 4 years, savannas and woodlands were 2 to 5 years, and forests were about 3 to 10 years. This is again according to the surveys from the land managers in the state. So here's what we did. This is how many acres were burned, and this is what the survey returned. We're falling well short of our target acreages burned. Whether we assume a 2-year fire return interval or a 3-year or a 4-year, we're coming short no matter what. And it's important to note that this assumes that everyone's burning different acres every year, and not just the same, rotating between the same 2 or 3 plots, that they're burning, new things every year. So you can see, looking at this, we're assuming a 2-year fire return interval, we're quite a bit short. We're, almost 250,000 acres short. And even if we assume the fire return interval was 4 years, we're still almost 100,000 acres short. So we're burning, but we could be doing better. Only one agency met the 2-year fire return interval for burnable acres. And then 7 agencies burned sufficient acreage to meet a 5-year or less fire return interval, which is pretty good. And then 9 agencies are implementing fire at about a 10-year plus fire return interval. So we're looking more like 10 to 15-year intervals than the 2 to 3, 1 to 2 we're supposed to be looking at. Again, the other problem we ran into was too many degraded acres. Illinois has more than 200,000 managed acres that are in dire need of intensive management and restoration. These acres require even more fire than the high quality acres we were just talking about. And if we can't put more fire on the ground across all ownership, and if the quality acres are being burned too infrequently, then these are definitely not being burned often enough, and that risks them sort of changing into low quality acres that can't even be burned, or fire won't even help really bring them back. And so now we're exacerbating the problem of there being too many acres that may not even carry fire. So it's a little bit of a dismal picture maybe, but I want to end on a positive note, and show you that for at least some of the land managers in the state, the acres they've been able to burn have increased markedly in the last 20 years. So if we look at Cook County, the red bars, that's part of the Chicago metro area. It's most of the Chicago metro area, in fact. They only burned 27 acres in 1996, and in 2013, they managed to burn a record 5,600 acres. So, and that's, again, that's the Chicago metro area. So they're figuring it out. They're doing what they can. So it is possible to increase the amount of fire on the ground as long as states and agencies are able to promote a fire culture and sort of overcome some of the major barriers to putting fire on the ground. And you can definitely read more about these trends, about that barrier, about those barriers, about all of these findings in the full Illinois Prescribed Fire Assessment report, which is on the Illinois Prescribed Fire Council website. I'll give you a link in a little bit. I just want to call out a few other assessments in the area that use LANDFIRE. The Michigan assessment, which was done in 2008, leaned fairly heavily on LANDFIRE data for the ecological conditions and the fire return intervals, and they developed a fire assessment and designed a process for analysis and planning that I think a few other states have sort of used theirs as a baseline to plan their assessments. I know we looked through it in Illinois to say, well, what did Michigan do, since they were one of the first ones to do it, and I think that Wisconsin sort of looked through the Michigan assessment as well. Speaking of, this is the Wisconsin fire assessment, which was also recently completed, sort of just before ours in Illinois. And so theirs is, it's interesting because they did a sort of cost-benefit analysis that focused on the fire return intervals less than 50 years and brought in some additional data sets to sort of say what is the cost versus the benefits of fire in these landscapes, and where should we prioritize if we had to pick places in the state. So the website where you guys can get that is under that. I imagine many people on this call are familiar with that since TPOS was fairly heavily involved. So I want to give you some context for, these are my Illinois colleagues. It's myself at the top. Jeff Walk is our director of science, and he was sort of my co-collaborator on making up fire return intervals and crosswalking vegetation data from one vegetation classification to another. So I like to say that he's got a PhD, so if it's wrong, it's his fault. And Bill Kleiman, who's the TNC's Nachusa Grasslands Preserve Manager, one of the largest grasslands in the area, and definitely the largest in Illinois, and really an impressive place, and they're doing a lot of great stuff with fire. He's also heavily involved in the Illinois Prescribed Fire Council. So then also here you can see, here's the contact info for Prescribed Fire Council, and then their website at the bottom. That's sort of where you can download this full document for the fire needs assessment. And I recommend that if you're interested in way more detail on especially on the end part of how we got the current numbers and the surveys and the results and all of that, all of that is in the document in much greater detail than I was able to give it to you today. So that's good. Okay, so thank you all, and I'm going to turn it over to Jeannie, and she's going to kind of wrap us up a little bit. But thanks all for your time, and hopefully you've enjoyed this, and certainly if you've got questions, we'll take a few now, but feel free to email me at any time, and I'll either answer them myself or send you to someone who actually knows the answer, because it might not be me.
Thanks, Sarah. I'm going to run through these URLs while you guys are getting your typing fingers ready. Chat box is open, so if you have any more, or if you have any questions of Sarah or clarifications or anything like that, please start typing now. I did put a few URLs in the chat box as well. A lot of you know us. The LANDFIRE program home is landfire.gov. And LANDFIRE has a presence on the Nature Conservancy's Conservation Gateway. You can find us there at nature.ly.landfire. We have a Twitter feed at nature_landfire. Our YouTube channel is LANDFIRE Video. I encourage you, when you go onto YouTube, to type in LANDFIRE Video. If you type in just LANDFIRE, all kinds of interesting things are going to come up. Most of them you don't really want to know about. We do bi-monthly bulletins and postcards via the MailChimp delivery system. You do have to opt in. So if you haven't opted in to get the LANDFIRE bulletin yet, here's your URL to do it. When all else fails, if you're not writing down URLs right now, you can always reach us at landfire@tnc.org with any questions. If you want to subscribe, if you need follow-up, that's a main email address that we're continually checking. And then a reminder about the BPS review website. We're going to open it up to questions here in a second, but I did want to give a little bit of information on the BPS review website. Sarah covered a bit of this in the middle of the presentation. We are calling for what we call expert review to go on in, download some Word documents in a region that you're familiar with. Those Word documents usually run between 4 and 10 pages. You don't need to know how to model to get in there and provide your expert review and feedback. You just do a track changes function on the Word document itself. And we've been asked along the way, what do you mean by expert review? You don't need to be a published expert or land manager, etc. You do need to know your neighborhood pretty well and be able to offer some constructive feedback, update, corrections, comments on areas that you know pretty well. So we have made a commitment that all documents and reviews that are returned to us by June 30th will be reviewed very carefully by our team and will be included in the next round of, I think it's called REMAP, as much as we can. After June 30th, we're still accepting reviews. We'll accept reviews forever, almost forever. And so just encourage you to bring that expertise that you have about your region to us so that we can really make a robust new biophysical settings product. I think with that then, I don't see a whole lot of questions coming up. You have Sarah's email address. You can always reach me at landfire@tnc.org, and I'll answer what I can and send your questions on to the rest of the team. And I think that takes care of it. Thank you, Sarah. Thanks everybody for attending, and enjoy the rest of your day.